Jai Hind to all. My name is Dhanshri Parihar, Assistant Professor, Department of Computer Science and Engineering, Akgec Garg Engineering College. And today, my topic for discussion is the Java Advanced Features, Part 1, from the subject Object-Oriented Programming in Java. So the content of this topic includes the description about base64 Java encoding and decoding of string using a Java program, and a try with resource feature in Java, that is an advanced feature added in a Java. The meaning of A notation in Java, how these A notations are being used in Java, their types, and the various programming examples for all these topics. So let us start with base64 encoding and decoding concept in Java programming language. So what is a base64 encoding and decoding and why it is used in Java programming? As a base64 encoding allows encoding a binary data as a text string for safe transmission of data and a cost-efficient way for a large data size. It is commonly used when there is a need to encode a binary data that needs to be stored or transferred via a media that are designed to deal with textual data like transforming the images or XML, JSON files, documents. For using this base64 encoding and decoding concept in Java, the package which used is Java UTI package, that is Java utility package, and the class name which will be holding all the we can say methods used for converting a given string into encoded string and then again decoding that encoded string at the destination point by using the class base64 in utility package. Here the two methods, one is the encode method and another is a decode method, is used to convert a plain string into a encoded string, and then when at the receiver end where it is being received, it will be decoded again into a plain string from an encrypted string. So the syntax for this implementation in Java programming is as follows. In this, we will take a base64 name of a variable, and what we are storing in that variable, this is a user-defined variable with the data type string, and in this user-defined variable, what we are doing, we are just holding the value of string which we are going to encode. How it is possible? By using a base64 class dot the get encoder method, which is used to obtain the value of the encoded string from our that particular string that will be converted into encoded form by using your encode to string method, and this string is being transmitted into a get encoder string and then into base64 class. That is the inbuilt method of this base64 class, and we are storing the value of that encoded string in a base64 format named user defined variable. So let's take an example how it is possible in programming language, and before that programming example we will see how this concept is being followed in a programming language. So what is base64 encoding and decoding, how it is possible, what kind of steps is being followed by these functions and that class to convert a plain string into an encoded string. For this purpose, we are taking a ASCII code characters, okay, that is American Standard Code of Information Interchange. And the algorithm for doing this conversion is, first we have to group the binary data and we have to convert each and every character into a binary conversion, binary equivalent of that particular character, and then we will group together a 6-bit of chunks of that binary conversion, and then the mapping will be done, and then it will be converted into, we can say when we group them into a 6-bit of chunks, it will be converted into its, we can say, encrypted form, encoded form. And then what is padding is done? Padding is done if some in that particular bunch the number of bits will be deficient. So we are grouping the bits to be in a group of 6 bits. If a last group will be having only 4 bits or 5 bits, so we have to insert an extra bit to that particular group in order to form that group in a 6-bit formation. So that concept is known as padding, in which we are inserting the extra 0 binary bits to the group in order to complete it particular group formation. And then reversible means we are the opposite of it will be used to decode that particular string, which will be encoded with the help of base64 functions. Let us see an example for that. So here this is a table of we can say the various characteristics showing their ASCII values, which will be present in our keyboard, that is American Standard Code of Information Interchange. And these are the binary conversion of these characters. So let us take an example. In this example, we have a word Vikas. Okay. V capital, then small I, then K small, A and S. Now we want to encode this. We want to encrypt this using base64 encoding concept in Java, and when it's encoded form will converted, then this data is being transferred on the network and then will received by the receiver. Now how this encoding will be possible using your base64 encoding in Java. So the character V is having the number 86, as we can see in this diagram. The capital V will be having 86 as our binary code. If we see over here, this is our capital V, and 86 is a decimal conversion. Okay, sorry, this 86 is its decimal representation. Now this V is having 86 as its decimal number, and this 86 is being converted into its binary form. So that is 8 and 6 we need to convert. Okay, so 86 is for V. Similarly for I, we are having 105 as its decimal number, and for K 107. For small a it's 97, and for S it is 115. We can perform a lookup from our this ASCII code table for the decimal conversion of these characteristics. Now after decimal conversion, we will need to convert this decimal equivalent to a binary representation of this character. Okay, for that binary representation, we need to convert this decimal number into a binary number. So 86 is an ASCII code for this character V, whose binary equivalent is 010101110. Okay, and for 105 it will be like this. These are all the binary equivalents of these characters. First they're converted into decimal number, and then they will be converted into their binary equivalents. Now after this binary conversion, the next step that will be followed by the algorithm is to join this particular numbers together like this, starting from the word V, then I, then K, then A, and then S. For V, like we are having 0, 1, 0, 1, 0, 110. This is for V. Next is I. For I, we will having this code 0, 1101, 001. And for next, similarly for K, we are having this code, then A and S. That has already been written in the slide. So these all numbers are written in a combination form like this. Okay, in a single string we are converting them. Now what we have to do next, we have to pair them in a group of 7 bits together in order to encode them as per the rule of base64 algorithm. So starting from the leftmost bit, what we have to do, we have to group 6 bit, 1, 2, 3, 4, 5, 6, like this. This is the first group. Then again 1, 2, 3, 4, 5, 6. This is the second group. 1, 2, 3, 4, 5, 6. Third group. 1, 2, 3, 4, 5, 6. This is the fourth group. 1, 2, 3, 4, 5, 6. Fifth group. 1, 2, 3, 4, 5, 6. Sixth group. Now what about this last group? We are only having 1, 2, 3, 4 bits in this particular group. And as we know that we have to group together the 6 bit for making that group combination for this base64 conversion. But we are deficient by 2 bits in this last group. So what we will do, we will add 2 extra bits. That value will be the 0 bits. We hold the 0 bit value like this, and we will complete this 7th group. So this phenomena of adding the extra bits to the incomplete group in order to complete into a particular group formation is known as a padding scheme, where we used to insert the extra 0 bits to our uncompleted group in order to complete it. So it is the padding step. Now, so we are having 7 groups, means, so the word Vikas, VIKAS, when it will be encrypted, it will be converted into 7 character of combination according to this particular code. Now the next step is converting these combination of 7 groups. Like first group, it's binary equivalent, decimal equivalent. Its decimal number will be founded. Okay, means the number will be founded. For the second, third, fourth, fifth, sixth and 7, the decimal equivalent will be founded. So like V is having this binary number of 100,110, and then we have I, K, and we will converting them. So the converted code, when we group the 6 bit of combination, is that I told you is there will be 7 character. 1, 2, 3, 4, 5, 6, 7. Okay, because we split that particular group in a 6 bit of group combinations, and we have a 5 bit of 5 character of word will be encrypted or encoded into a 7 character word now, and this encrypted data can be sent through the network, can be transmitted to the destination. So this is the way this we are doing the base 64 encoding in our Java program. This is the part of encoding, and opposite of it, converting this given string back to this word Vikas is known as encoding, and the same opposite phenomena will be formed for this. But in Java, we do not need to solve this algorithm. There is already a class named as base64 holding the encoding and decoding function that will be automatically converting a given string Vikas into its encoded form. So this is a manual technique I have shared with you. The original and this manual technique will be implemented with the algorithm and will be implemented in a form of a program in Java, which will be done automatically. Let's have a look at that program. So this is the program for encoding the string Vikas to base64 conversion. For doing so, as I told you earlier, we need a utility package holding the base64 class in a Java package. Okay, we need to import it. That after importing it, we will create our own class, base64 example class, and then we have a main method as we start our Java program. So here we are having a original input named variable which will be holding a string value Vikas, that data type, which will be having a data type of string. So Vikas is a string and we are holding it in a original input named variable. And for encoding it, we will be creating another variable named as encoded string variable. And what we will do, we will be converting this Vikas into VMLRKR, that 7-bit character encrypted code of Vikas that I have told you earlier manually. That will be done with the help of this function automatically. Okay, so for doing so, we will be using base64 class, then dot its get encoder method to obtain the value of encoded string. So for doing so, the main method is this encode to string. What it is encoding? It will be encoding the original input. Okay, what original input is a variable which is holding the character string Vikas. Okay, so the Vikas dot get bytes. So we are converting this Vikas character string into your binary bits, into bytes, and that binary bits will be encoded into your those character again by grouping them into a 6-bit of group formation. Okay, that will be automatically done by this encode to string method. That whole complete method is done by a single function, and the work of get encoder is to obtain that value from that particular class. Okay, get method to obtain the value and hold that value. Now in order to print that encoded value of that Vikas, that is VMLRKR that we have converted, that will be printed by this system.out.println statement, that is the output statement used to print some string in Java, and what we are printing encoded string. So encoded string is the variable which we will be holding that value. Actually, what we are doing, we are converting it to be VMLRYXM. This is the conversion of word VIKAS. Okay, and we will be having, after conversion, we will be having this value for this string. So after running this program, the output will be as this VMLRYXM, which I have previously shown you in a manual method. This VMLRYXM, which is the decimal equivalent of this particular grouping, which we have done manually. That will be done by a single, we can say, method encode to string, and then get encoder method will be holding its value. So this is the way how we will do the encoding part. Now for doing the decoding part, again converting this VMLRYXM to Vikas, some other functions are used. The program for converting the VMLR string to Vikas again means decoded, encoded to decoded part, coming back to the source. For doing so, the program is like this. Again, we are taking this base64 class with the utility package, and then we have a base64 example class with public setting point method starting its execution, and then we are having this encoded string named variable where we are putting this VMLRYXM equals to. This is the complete code. Okay, 1, 2, 3, 4, 7, and this will be holded in this encoded string variable. Now what we have to do, we have to convert it into a decoded form. For decoding the string, the first we have created a variable named as decoded bytes. Okay, that will be of kind of a byte data type. It will be holding a byte data type because we are converting it into byte format, okay, in a decimal form, and then we will be getting its character value. So again, base64 dot get function is there, but this time it is not encoded. It is a decoder function which is used to decode it, and then decode a function again to get the decoded value, get decoder, and dot decode to decode that encoded string. So encoded string value is holding this VMLRYXM. Okay, and this will be decoded by using this decoded function into what? Vikas. So the complete this method string will be returning the word Vikas to this decoded byte variable. And when we are printing this decoded string, what we are doing? Okay, in decoding byte, first of all, its byted value means its character value, binary value will be stored, and then it will be converted into character value. For doing so, we are using this decode byte function again, and we will be giving to decode string and converted into a decode string named as VIKAS. So what we obtain in the output, that is Vikas. That is a conversion of VMLRYXM to Vikas. So this is the way how we can encode and decode the strings in Java for secure transmission of data, videos, and we can say text over the network. The next topic is try with resource features in Java, which is an advanced try block in Java programming. So in exception handling, we have already studied the try block, but previously in try block, it do not have any parameters. The block is generally used to monitor the code for some exception. If the exception will occur, a catch block will be inserted along with the try block, which will handle that exception. But this try with resource is an advanced try block that will be having a parameter associated along with it, and we are passing the object of the file or any resource whose availability needs to be judged by the try block. So how it is possible for this try with resource, that is advanced try block in Java. This is the syntax for this advanced try block in this. As I told you that try keyword is not individual keyword, it will be having its parameters also over here. So we are declaring the resource name over here, and we will be judging that resource, whether that resource is available or not available in our system. If it is not available, then the control will be transmitted to the catch block for exception handling. That means that particular file, that particular resource, that particular hardware is not found in our computer system, and that catch block will become functional. So let's take an example of a program, how it is being used in a Java program. That is the advanced try block, that is try with resource. So there is a programming example for this. In this programming example, what we are doing, we are creating one simple class. We are importing the input output package also, because this example is example of the we can say file handling in Java. Here what we are doing, we are just checking whether that particular file is present in our system or not. If it is present, for its presence we will be putting it in the parameters of try block and checking its present. If it's present in the system, then the try block is being executed. If not, it will be throwing an exception, and that will be handled by a catch block. So after getting this class, this is our main method has been started. This is the try with resource block. Here what we are doing, you can see over here, we are just creating an object of what? File output stream. What is this file output stream? This is a class which is being used to write or insert the data into a file, a folder, we can say text file, a word file, by using a Java program in our computer system. So here we are using file output stream class, its object. Then after creating an object, we are passing the name of that particular file where we used to perform the writing operation, that is gfg text file.txt. So we are putting this complete object creation and that file name inside the parameter of this try block. If this particular file is not available in the system and this object is being created is not of any use, not opening, not instantaneing this file, in that case we will met with an exception, file not found exception, and then the control will be transmitted from this try block to your catch block. Okay, but if it is present, then the try block is being executed. So inside the try block, what I have written, I have taken a text named variable of type string, and what I want to insert into this file named as, my file name is gfg text file.txt. So it is a notepad file I want to open, which is present in my system. So before its presence, I need to create this file in the system, that then I am able to ensure that I can perform a written up. If this file is not being created in my system, then I am not able to insert any data into this file. So I have created this file in my drive, and then with the txt extension means a notepad file, and it's an empty file. Then after using this program, what I was supposed to do is I want to open this file, and then I want to write this string hello world, this is my Java, into this file. So what I'm doing, I'm holding the value of this particular string in text variable. Okay, hello world, this is my Java program. And if I want to write this particular string into this gfg text file.txt, what I want to do, I want to insert it into the text variable. And in text variable, how I can write it, by using text.getBytes. It will be holded in the ARR variable of type array, and then for writing operation, the object name FOS, that is the object of this file output stream, and the write operation will be performed on AR. ARR means that array which will be having this particular string value indirectly. So this hello world is not directly written into my file. For writing it, I need to convert this each character into its binary code in its byte, in its location, and then hold it by a text string. This string is being holded by an array, and that array will be written into with the help of this object force, it will be invoked and written into our file gfg text file.txt. So this code will be executed when the try is run successfully. If in case this file is not available in the system, not found in the system, this catch block is being executed. So in this program, this file is present and the try block is completely executed, and the program will jump from this control to the end of the line wherever this catch blocking is completing here. Okay, so we are displaying a message, resources are closed, and the message has been written into the gfg text file.txt, and the catch part is not going to be executed till our try block is running in a true phase. Okay, let us see what is the output of this program. So after executing this program, what I got in my after compilation, I got that these resources are closed and the message has been written to your gfg txt file.txt, the file name which I have given in my this program, whose value is being passed to the we can say default constructor where we have created our object. So how I come to know whether this data has been written to this file or not? So what I will do, I will go to my this folder where I have created this file in our Java, along with our Java bin files, where I have installed my Java. I have created this file gfg.text.file. Previously it was empty when I have created it, and after execution of this program successfully, when I open the file, what I found? Hello world, this is my Java program. So I have not written this content manually into my file. This content is being written by this Java program into my file, which I have located inside the same package, the bin file, where my JVM is installed. So this is the way, this is the use of try with resource block in our Java programming. Hope you like my videos and lectures. Thank you and Jai Hind to all.